In this video, we will be adding complex numbers. To add complex numbers that are in rectangular form, all you need to do is add the real parts and then add the imaginary parts. So on this problem we have here, our real part, and the first one is 2 root 3, and the real part on the second number is 2. So when we add those, we have 2 root 3 plus 2. Then, after you've done that, you add the imaginary parts. So the imaginary part for the first number is 2i, and the imaginary part for the second number is also 2i. So when we add those, we have 4i. And that's our answer. You can also think of this as combining like terms, because these terms in the back, the imaginary ones, have the I component. Now, if we are wanting to add complex numbers in polar form, complex numbers written in polar form cannot be added in that form. You have to first change them to rectangular, add them together, and then change back to polar. So the problem we'll be working with is 4 CIS 30 degrees added to 6 CIS 60 degrees. So I'm going to draw a little sketch for this. We have theta is 30 and r is 4. And to get this to rectangular form, we want to find our horizontal component and our vertical component. Remember, this is our real axis and this is our imaginary axis. And then our sketch for this one, our theta is 60 degrees and our r is 6. And again, we want to find the real component and the imaginary component. Right, now these are both our special triangles. The side opposite the 30 is half the hypotenuse, so this is 2. The side adjacent to the 30 is half the hypotenuse times the square root of 3. Or if you want to think of this as being the 60, it's the side opposite the 60. So that'll be 2 root 3. On this one, the side opposite the 60 is half the hypotenuse times the square root of 3. And that'll be 3 root 3. And then this is my 30-degree angle. Half the hypotenuse will be the value for my x here. Right, so what I have then is 2 root 3 plus 2i added to 3 plus 3 root 3i. Now when we add our real parts together, we have 2 root 3 added to 3, and then our imaginary parts will be 2 plus 3 root 3i. Now we need to change that back to polar. We need an r value, and then we need a theta. So our r can be found with the formula x squared plus y squared square rooted. Now this is just the Pythagorean theorem. I square rooted both sides though. So instead of r squared equal x squared plus y squared, I have r equals square root of x squared plus y squared. Right? This is our real part, so that'll be my x. And this is my imaginary part, so that'll be the y. So for r, I have square root of the quantity 2 root 3 plus 3 squared plus 2 plus 3 root 3 squared. Now I want to get this calculator ready, so that's why I did that. I don't do the calculator until the end. Let me go ahead and write theta also. Remember, theta is arctangent of y over x. So in our case, theta is arctan of 2 plus 3 root 3 over 2 root 3 plus 3. So let's do the r first. We have square root of, and we want the quantity 2 root 3 plus 3 squared plus the quantity 2 plus 3 root 3 squared. It's like 9.67. And theta, we want arctan, and then the quantity 2 plus 3 root 3 divided by the quantity 2 root 3 plus 3. And that angle is 48.1. So our answer, written in polar form, we'll use the shorter method for writing it. So it'll be 9.67 CIS 48.1.